So we've kind of established the surface is a bit shitty, largely.
Yeah.
And as I was just saying, potentially what we don't want to contaminate is the deep subsurface. So although the surface is crappy, there is a lot of potential that deeper down below the surface, where it's not going to be as cold, there might be some residual kind of geothermal heat.
Yeah, sure.
This should be.
Yeah.
And there's, the UV's cut out, the pressures are higher, all these types of things, that there could be habitable environments in the deep subsurface of Mars still. And that is potentially where we want to be looking for modern Martian life. That's really where most future Mars missions that are directly life detection missions will be aiming for.
Yeah, absolutely.
The subsurface and the deeper subsurface.
Yeah, I mean, it's so much more likely that if there's anything living on Mars, that is where it's going to be.
Yeah.
Even if there was a prospering biosphere way back in like 4 billion years ago in the Noachian,
it probably would have
it would have retreated underground. I mean, it would have been colonizing the subsurface then as well.
Yeah.
But obviously, as the surface dried and became like it is now, you would just be left with that subsurface. Yeah. And the discovery in the last however long, few decades, I guess, the subsurface of the Earth is packed full of.
It's crammed full.
Yeah, it's crowded.
Yeah, it's crowded.
It's the most extensive habitat by orders of magnitude.
And
some people reckon that it's most of the biomass by quite a significant margin is in the subsurface of the Earth.
Yeah, I don't think that's true.
Oh, really?
Not biomass.
Okay.
But a significant portion is in there.
Yeah.
But it's not as high as was initially thought.
Interesting.
There were some people that thought it was particularly high, 30-something, 40%, or a huge amount. But that was because they were sampling in
particular areas,
subduction zones and things that had much higher biomass with things being buried. When you sample away from them, they find far less.
Interesting. That's cool. That's interesting.
Something like.
So it's really sparsely distributed.
It's being pushed down from 30% down to 1 or 2% of the carbon weight of the biosphere.
Yeah, I guess that does make sense when you think about the oceans.
Yes,
which are just like tens of millions of bacteria per milliliter of seawater and that kind of thing. Yeah. You're probably not going to get that level of biomass.
But there is a lot of.
But there is a lot of stuff down
That's
there.
1% still hugely significant.
Yeah, massive.
And. Yeah, I mean, we've both been into parts of the deep subsurface to look at organisms in the deep subsurface. So, we're not going to go too much into our own work, but we went into a mine to look at organisms that live down there in this 1 kilometre deep mine.
Yeah, which was a nuts experience.
Yeah, which was crazy. And should we talk about that?
Yeah, could briefly talk about that. Well, you've been down loads.
I've been down loads.
That's your thing, it's going down there.
So, should we talk about the whole experience?
Screw it, yeah.
Well, we basically ended up going down. I've been down this mine loads of times. You came down to help for sampling once, and been down.
I've been down twice. Yeah, been down twice. Yeah.
And you basically go kind of, I suppose, you go about 1 kilometre down the main lift.
Yes.
Which takes about 6, 7, 8 minutes.
Something like that.
With all the miners.
It's a working mine.
It's a working mine.
And there's 300 people underground at any one time.
Yeah.
So you're in this cage in the lift shaft with about 60 miners or something, all just rubbing shoulders.
Yeah, and it's obviously it's totally safe and stuff, but it feels like a proper kind of industrial mine. It's a bit of a throwback in a way.
Yeah, first time I walked, I don't know what I was expecting, kind of gleaming like just high tech looking stuff, industrial, but I don't know. It's just it just looks like it's been hammered together with hammers and nails.
Well, yeah, it has. It's got no veneer of kind of. It's not sanitized in any way. It's very much nuts and bolts, functional. Yeah. Concrete and steel.
Yeah. And everything's covered in dust.
Yes.
Which gives it that kind of super old kind of derelict look.
Yeah.
Even though it's not at all.
No.
It's totally safe and good and fun.
Yeah. And so we do this journey down. Takes about 8 minutes, 6 minutes, whatever it was, and then travel out right into the far reaches of the mine. So drive up to 14 kilometres out under the North Sea.
Under the sea.
Yeah. To go and sample brine seeps and seeps down there and to look at life living in the deep subsurface. So we have, in a way, first-hand experience of how much stuff there is living down there. Obviously, you can't see it in the rock, but as soon as you get back and
take it to the labs, you
can stick it in nutrient media and it goes crazy.
Yeah.
So yeah, the deep subsurface on Earth is packed full of all sorts of things.
Yeah. And the cool thing is that it's isolated from sunlight as well.
Yeah.
That's the thing. Like people say, like, oh, on Mars, if you had a deep subsurface biosphere that's separate from the surface, how could it get its energy? Because it doesn't have access to sunlight. Well, the deep subsurface on Earth has like whole communities of organisms that are like primary production is not based on sunlight. It's just based on chemical energy. So you can have a total. Yeah. Well, I know that the story on Earth is much more complicated than that. But it is possible. But all I'm saying is it is possible to have communities that are completely sustained without sunlight input at all.
Yeah, it's thought that it's possible.
Yeah.
But most of the Earth's deep subsurface biosphere probably is
has
not like that.
Some input from the surface.
Yeah, like buried carbon. Like stuff has been buried. But yes, certainly it's possible that you have this like primary production.
It's theoretically possible if it's actually happening on a large scale on the Earth and the subsurface.
It's a bit of a mystery.
Is a bit of a mystery.
Yeah.
But it's certainly possible to produce energy for a whole community without sunlight.
Yeah.
So we know that the deep subsurface of the Earth is an extensive habitat and supports loads of stuff. So it makes sense that the same like region of Mars would also potentially be a habitat. And like the thing that we didn't mention earlier is water. There's probably quite a lot of water down there.
Yes.
Just because we know Mars has a lot of water. We know there's loads of ice in the soil and permafrost and in the ice caps. We know that the planet has water.
Yeah.
And like
you think back to Phoenix when it scraped back that like region right next to it. It was landed in the northern hemisphere, didn't it?
It did,
in the northern lowlands, and like directly under the soil, just
ice,
chock full of ice.
There we go.
Of water ice.
Yeah, water ice. Yeah, delicious water ice. So it makes sense that as you go further down, the pressure, as you're saying, the pressure increases and the heat probably increases.
Yeah, there'll probably be a different like heat flow regime to that on Earth. So Earth probably is a bit higher. Earth's more geologically active and stuff. So you might have to go deeper into the Martian subsurface till you hit a habitable zone and a region where liquid water exists.
Yeah, but I mean,
certainly it would heat up.
It would heat up and probably into the zone of liquid water being around, like as in into the phase. Into the phase liquid water would exist probably.
Yeah,
very very likely. And actually, because of some people even speculate that because Mars has lower gravity. There's less density as packing of material.
Yeah.
You could potentially have higher pore space than you do on Earth.
That's definitely true.
So it looks like the deep subsurface is like a really good place to look. If we want to look for life, it makes sense to look underground. Yeah. Get away from that horrendous surface.
Away from the cold into the warmth.
Yeah.
I mean, we've been like in the mine. Think how warm it is down there.
Yeah, good point.
I mean, the geothermal heat's quite high there. I don't know why, but it's particularly high in that environment. But I mean, in the mine, in parts we're in, it's like 40 degrees.
Yeah,
really hot.
Really, really, really hot.
Sweaty.
Yeah.
Well, actually, it was over 40, wasn't it, in parts?
I think it got up to like 50 in one particular bit.
Yeah.
Nearly 50.
And the miners just work down there, and
they're just used to it.
Yeah, they're just hardcore.
They just have a system, and they just get on with it.
Yeah,
and they're hardcore,
like keeping themselves cool and doing all these types of things.
But I think it was cool. January that when we went down.
It was January.
And, we live in the UK, so January in the UK is cold. So you go from cold, like freezing cold on the surface, to like 50 degrees underground. And we're talking about 50 degrees C, by the way.
Yes.
Just in case there's any, not 50 degrees Fahrenheit, because that's not very cold.
And when you're in the dark of a mine, that 50 degrees feels... I've been in 50 degrees on the surface,
it's like an oven.
And it's not the same. It feels much more intense.
It's oppressive.
Yeah, because it's dark and small, and 50 degrees is not.
You feel like you're like crawling into the center of the earth.
It feels it does.
This isn't. Humans should not be here.
Yeah, and life,
But life's loving it.
It's fine.
Yeah,
it's crazy.
Yeah. So I mean, again, that's the Earth, but you would expect a geothermal gradient on Mars and liquid water underground.
Yes.
So that is where we should look.
There's also caves and stuff, isn't there?
There are caves. Yeah. There's caves which could obviously provide like shelter from the surface extremes. Yeah. Also, it could provide us a way of getting into the subsurface easily.
Yeah.
To look at it.
There's people looking at that sort of stuff. I think working out how to explore caves on Mars and that kind of stuff. Yeah.
They're like lava tubes and stuff, right?
Yeah, lava tubes.
Like collapsed lava tubes and things.
You get like skylights through them.
Yeah. Oh man, I bet they're cool. They're huge. Some of them.
Yeah. Massive. I mean, like potentially in the future, humans will go exploring into them.
Imagine like
you send robots
into
in and
one.
Stuff.
Just like lowering yourself down.
In the new Star Wars movie, when she comes through the skylight of the
Yeah, exactly.
Like a Star Destroyer.
Yeah.
Like that.
Yeah.
On Mars. With your...
I can't wait for that.
Oh, yeah. You'd have to have... It'd be crazy trying to explore stuff like that. All the kit you'd have to like lower yourself down in like a spacesuit.
Yeah.
You have to have like a rocket pack
to get back out again. Yeah. Or just climb back up the rope.
No.
Oh yeah, what am I saying? A rocket.
The rocket pack, man.
Yeah, definitely. And then one day we can like roof them over, like dome them over, and like and have like a city inside. Anyway.
Well, people have talked again. That's been talked about. Of
using
trying
it as
to
a
set
habitat.
up as a habitat in a cave, a lava tube.
Yeah, because it's the protect, like
you just get some extra protection.
Yeah, the protection's already there. You don't have to build it or take it with you.
Yes. You still have to take some protection,
of course. Yeah.
As in like air.
It's like now we're in the cave. Just take off the spacesuit. Be fine.
Dead. And all the nasty stuff. It'd still be perchlorates and all the bits and bobs that were blown in there over the years. But you could. It's definitely a favourable place. You might be able to get. The atmosphere might be thicker in there as well if it's deeper down.
It's deep
and
enough,
stuff.
Yeah, sure.
You might get some moisture forming in certain parts of the caves. Maybe as they go deeper down, it gets warmer. Depends exactly. Some of them are near volcanoes, so there might be a higher heat flow. So yeah, they're a good place.
Caves are promising. There's also like there's the ice caps, the polar ice caps. So like if you look at Antarctica, for example, on Earth. You go underneath the ice, which is in places like 3 miles thick.
Yeah,
which is insane.
Yeah. 3
miles of it's just a frozen ocean.
Yeah.
Underneath that, you quite often find liquid water. So either like lakes, like sub-Antarctic, subglacial lakes.
You might have heard of Lake Vostok and others.
Which are really cool. I mean, there's like ice sealed.
It'd been sealed for hundreds of thousands of years. Sealed. I mean, they're all interlinked with each other, and they probably at the edges link out to the sea. But they've been covered with ice for a very long period of time. Yeah.
What was the one recently drilled into, and they found a fish?
Really?
It was nuts.
Was it how far from the edges though? Was it?
It was. I can't remember exactly. I can't remember the details. It was close enough for it to not be like that mental.
Yes.
But nobody had actually known that there was any kind of connection at all.
Yeah.
And they just like lowered a camera down this like, a few hundred meters or whatever it was. It wasn't quite the 3 mile stuff.
No, it wasn't like Vostok,
no, I think it's like 700 or 800 meters. And like lower the camera in, and it's like this little fish swimming around. It's like, what? Underneath Antarctica there is a fish. Yeah, anyway, so it's probably connected to the sea.
Yes.
Is what that means. How is that relevant? Oh yeah, the point is that underneath these ice caps on Earth, you find liquid water. So the same could potentially be happening on Mars. Yeah,
because there's increased pressure.
Yeah.
You get potentially a layer of liquid water.
Yeah.
It could potentially happen on Mars under the ice caps, or even deeper in the ice caps, but also in the sort of subsurface of the ice caps.
Yeah.
Not just underneath the actual
layer not just at the contact.
Into the, exactly,
yeah.
Then you could get the melting of ice and things.
Yeah. And there's other places on Mars where they reckon there's like glaciers and stuff. So again, like same kind of thing applies. There could be potentially places to look. So all of these places, like caves, subsurface, ice caps, they're all places where you're protected from the super extreme radiation and pressure and temperature, and you probably have much more stable like liquid water environments down on the surface. So like they are where we want to be looking.
And in terms of missions that are going to do that, we talked a little bit last week about ExoMars.
We mentioned it,
which isn't going to go too deep into the subsurface, about 1 meter or 2 meters. You said 2 meters.
2 meters, 2 meters,
which
if it lands.
If it lands, again, we talked about Russians having a slightly dodgy history of landing stuff successfully on Mars. But anyway, it's going to land. Let's hope it. Hope it does. It will have a drill that will be able to get us our first proper subsurface sample, or with some depth. The Curiosity rover has a little drill.
It's like 5 centimeters.
Yeah.
Which is actually, to be fair,
that's
massively significant.
Yeah, that's still a huge deal, because you see from the drill pictures. From the drill hole pictures, there's, as soon as you get through, like maybe half a centimetre through, it's all that red oxidized stuff goes, and you just get to like fresh rock suddenly. So it's only a very thin layer of this kind of horrible red oxidized surface that exists on on Mars. So a 2-meter drill. I mean, that's big. 2 meters. 2 meters.
2 meters is a lot when you think about that compared to 5 centimeters.
Yeah.
And what we found with the 5 centimeter one, like you were saying, like you get through there, and suddenly you just find all the, like on the surface there was certain things missing from like what life requires in terms of chemistry. Drill a 5 centimeters in, and suddenly like there's a whole diversity of things.
Yes.
So 2 meters down, like, you know, Christ knows what we'll start finding. Whether that's deep enough to actually start impacting like liquid water, like environments and possible habitable, probably not. But it could be super cool, like what comes up.
Yeah, I mean, you could get things are going to be much better preserved 2 meters down than they are close to the surface. So, great place to sample all types of different rocks that are down there that are going to have all sorts of things to tell us about the ancient past of Mars.
Yeah.
Even if it doesn't contain modern biology.
Yeah.
But I mean, who knows? And if we colonize Mars, of course, we'll be able to do proper drilling projects.
Oh yeah. Like deep drilling.
Yeah, like oil.
Like what we
like
do,
that.
like here, like
get some.
Like kilometers.
We'll be able to survey the ground as well with like ground penetrating radars and things. Be able
Find
to seismic surveys and find the aquifers if there are any, and then target them and sample them.
Yeah. I mean, the answers will come thick and fast then.
Yeah.
If we start dropping boreholes into the Martian crust, into aquifers, and they're coming up with no life in them, it's like, probably nothing on Mars.
Yeah,
at least now.
And we would be able to, again, we talked about it last week, we'd be able to, through looking at the rock record and isotopes and all these other things, we'd be able to probably determine if there has ever been life on Mars.
Yeah.